Hello CE8 students. In this video I want to discuss what backsights and foresights are so we can better understand what we're measuring whenever we do our differential leveling circuits. So we've already discussed that in differential leveling the idea is to establish new benchmarks for future use. And we do that by using pre-established benchmarks and then creating differential leveling circuits to get to a new point, establish an elevation, and then we close the circuit by coming back to our original benchmark to verify that we haven't committed any egregious errors or that our equipment is giving us bad data, so we can know that our final elevation for our new benchmark is correct. However, when we record that data, we typically record it and talk about backsights and foresights, as you saw on the table in the previous video. So let's talk about the setup as well as what a backsight and a foresight is. So, just like the peg test, we're going to call this benchmark 1. Okay? Or as we noted in the last one, that's VTA benchmark 216. Okay? So we would have our surface here. We put our Philly rod here. Set up our level there. And then somewhere we have another Philly rod that we're going to walk over to set up and take a visual of. So, if this is our VTA 216 benchmark that we talked about in the last video, if we sight this in, okay, we know that we have multiple variables here that we can label here. We've got this one here, which is HI, height of instrument. It's the distance from the ground to the center of the lens of our level in the or if we have a total station, it's still the center point of the lens in the total station. Okay. We've also got this, which I'll call E1. Okay. We have this, which we previously called E2. Okay. In the peg test, this is what we labeled everything. In essence, for differential leveling, it's the same thing, but we're going to have a lot of elevations throughout. And typically we want our elevation to be the actual elevation, such as in this one was 86.16 feet. Okay? So we typically want to use the E variables for that. So we're going to use new variables here instead of E1 and E2. We're going to call this our backsight. We're going to call this a foresight. Okay? And that's what our stuff means. Whenever we look back, we're going to take a reading off of this Philly bar, wherever it is. And we'll say, once again, we'll just call it 4 feet even, so it's easy to work with. Okay? And if we knew that this was our original elevation, then we know that if we take our elevation plus the backsight, we're going to get to this dotted line. Here it's a dashed line. This dashed line is perfectly horizontal because this is what we're seeing when we look through the auto level, and if we've done our stuff right, this auto level is flat. So adding the elevation here plus this BS will get us this dotted line, which, as we've noted, here in the middle is HI. Okay? So if we take elevation plus the backsight, then we're going to get 86.16 plus 4, which gives us 90.16. So now we know that this dashed line is at an elevation of 90.16. Okay? We don't actually know this small HI, but we do know the height of the instrument compared to sea level, just like we know that this is to sea level, and we know the height to that line. Okay? So we have this, and this is our, I'll call this HI sub E, because we know it's our height of instrument elevation. Okay. Once we do that, we shot our back sight. Now we have to get a measurement for this foresight. Okay. So we'll once again do this, and we're going to say that this one comes out to be 4.5 feet. Okay. Because we don't want them to be the same. That makes it too easy. Okay. So we know the height of this dotted line. Now we're going to try to find the height of this point on the ground, which we know has to be the dotted line minus whatever our foresight is. And we know the foresight is the distance from here to the ground, 4.5 feet. So we'll simply take HIE minus FS to get our benchmark 2 elevation. Okay, so in here it's going to end up being 90.16 minus 4.5. Rather than trust my brain, let's just trust the calculator. Say 90.16 minus 4.5. It's 85.66 feet. So what does that mean? We know the elevation on our first benchmark. By adding the back sight, we got the height of this dotted line. We know that dotted line is perfectly horizontal, so we can subtract the foresight here to get what the elevation at that point is, which here would be 85.66. So this means that this land here is half a foot lower than our original benchmark. Okay. The field obviously could be higher or lower. We don't know. But we do know we can use this math to find how they're related and the difference. Okay. Now in here I've drawn a straight line, but keep in mind that this doesn't have to be straight. This line could be super jagged. I could have a hill or something that looks like that. And let's say I know what this elevation is. We'll call it benchmark 1. And I have a filly rod that's tall enough to be here. And I actually want to know the elevation of this point right here. So we'll call it benchmark 2. Okay. We got to set our tripod up high enough that it could see the filly rod at both things. So we'll go ahead and set it up right here on this little hill. Okay. Okay. Now keep in mind there is a max distance that these can be, but we're going to assume it's within the max distance. Okay. And we would do the same thing we did before. We've got our dotted line that matches up with this. We've got our benchmark 1. We've got this distance here, which is our BS. Okay, we've got a distance here of HI. Okay, we're not going to be able to find that without measuring that specifically, but we are going to know this to the sea level, wherever that is, to sea level. Okay, just like we know that this one, whatever it is, will be to sea level. And then we're going to also have this measurement, which is our foresight. And the way it works is exactly the same. We would simply take our original elevation, add our back sight. That gives us our HI sub E, which is the height of instrument above sea level. And then with that, we subtract the foresight, and that gives us the elevation of that point. Okay. And you can see that the changes in elevation can be much more prominent than obviously what I showed here with a half foot. On campus, it might be that small. But if you're up in the Santa Cruz Mountains doing surveying for a new mountain road, these distances actually, as well as the height differences, could be far greater. Okay, so that's what backsight and foresight are referring to. Okay, and keep in mind that this is called the backsight because we're looking back to the previous benchmark, and this is called the foresight because we're looking forward to the next benchmark, and that's where those terms come from. In a future lab, we'll actually talk about HI itself and how to find that. That's actually quite simple. But for now, just know that whenever we add the original elevation and the backsight, we're getting height of instrument above sea level, okay? And then when we subtract, once again, we're getting elevation of our new benchmark above sea level. Remember, if you do have any questions about this, feel free to email me. Feel free to send me a message on Canvas. We can either schedule a time to discuss this stuff one-on-one, or you can stop by on my Tuesday office hours, and we can discuss that in length there. I can also screen share and talk about stuff, so be sure to give me a holler if you need any help, okay? All right. Otherwise, good luck on Lab 3.